Thank you for gathering on today's topic. I hope it will be interesting to you. At least it will give you some better understanding of not only the Hadoop environment, but also some engineering and analytical techniques that are possible within the tool that I'm going to present and work with during our meeting today. How we will proceed is that I'll shortly introduce myself and also the Presto tool. Then, since I believe not maybe everyone is familiar with the Hadoop environment, I will quickly say a few words about it and how basically a database is organized within this within the setup. And later we will turn to some examples. First of all, we'll see what it really means to work with Hadoop and how we work with data in that environment. And then we will be, I have some examples on how you can apply or like use Presto within not only the environment that I have prepared for us, but also within your organization if this will be applicable or you find it interesting to at least try it out. One comment also, if you have any questions, please either raise a hand or write them in the webinar chat, and I'll try to answer them as soon as possible. So not losing any more time, let's start maybe from who am I. I do, as Daria said, I'm a big data engineer. Recently also turned to more about software development that deals with big data or big data environments like clouds and of course Hadoop. But in my spare time, I am interested in IoT. I have been playing for volleyball already like for 12 years and have also experienced some semi-professional career in football. And also my interest is in financial markets, and in the picture you can see a robot that has basically been built by myself that streams data from 2 cameras, and currently I'm trying to process this and create a 3D visualization from the environment. Regarding now the topic, what is Presto? I believe this is the most important question to answer today. It's basically an SQL query engine. I believe you are familiar with some tools that do that. You can know, for example, Impala. You can use AWS Athena. Presto is one of those tools that are of the same group. It's not a data warehousing solution or database, as for example, Postgres or SQL Server. Presto, as you can see, is or Hive is a data warehousing solution within the Hadoop environment, and Presto is built on top of that, meaning that it uses some features that I will describe in a few seconds, or we'll take a closer look at them in a few minutes. It is an open source tool. It was firstly invented in Facebook, and it was released almost exactly 7 years, or a bit more than 7 years ago to public. Since then, it was quite extensively developed. So right now, if you look at the Presto page, the version is 0.232. I have been working with this since the version 0.158. So it's quite a long time. What I really like about it is the most, among other features that we'll see in a few minutes, is the UI that gives you not only the overview of what's happening within your cluster or what's the memory usage, but also very many details that we will take a closer look soon. Since this is open source, you can find it on Maven. You can easily build it on your own or modify features of it. If you want to add some UDFs, then you are free to go. There is plenty of documentation how to do that, except that we have a lot of tools that were developed alongside, like for example, libraries for Python, Ruby, or Go. There is also a separate tool which you can find a reference on the Presto DB site to the Presto admin, which is a program that helps you administrate the whole solution. It also supports ACID transactions. As you know, within Hadoop environment, the ACID transactions were not available for quite a long time, but since the ORC file type was introduced, it became possible. And then it also supports this kind of a setup if you have one in your environment. There are different ways how you can deploy it into your environment. One of them is deployment on Yarn via slider, for example, but I wouldn't recommend it because it simply freezes your resources available in the cluster. Usually when I did deployments of that tool, it was on a secondary name node or on an edge node where you deploy coordinator, and it works basically the same as Yarn. So you have a coordinator and workers, where you deploy workers on your data nodes. Or if you like, it can be completely standalone. So the workers can reside somewhere else, but then you will basically have some problems with the networking. But the deployment is not a topic for today. If you would like to know more, then please reach out and we can talk about it. Then I have provided also a few examples what it means to be an experienced user within this. So except that, as you know, of course, SQL, you need to know that, for example, if you would like to have a double type, then you either need to cast the number of as double, or the other option is to basically type 5 dot, which means that there are some decimals, and then it will be automatically converted to a double without cast. And then another thing is if you work with this tool, it is good from data engineering perspective, but also from your experience of working with this and sharing resources with other people to know the internals that I will show you how you can see or analyze the execution of your query to get straight to the point where are the problems or which stages can actually be improved in terms of not only time required for processing, but also resources. The last thing I would like to mention about that is that about a year or a year and a half ago, since Presto was owned primarily by Facebook, and they were also defining how it should evolve. Some of the developers decided that they don't want to follow this plan for development, and so the Presto SQL was created. It emerged basically from the version 0.218, if I remember correctly, or 16. Anyway, from that point, these two tools started to diverge in different directions. And if you are interested, then please follow the commits to both actually from that very moment. So you will be able to see what are the different features. But basically, the whole engine hasn't changed. Of course, there were some changes I saw in Presto SQL done to how they operate or how they run the queries, but in general, the idea and the main flow has remained the same. I believe that's enough for an introduction. Is there anything that you would like to know more, or you would like to get a better overview? What are the differences? Maybe I'll quickly say that Presto differs from the Yarn model, where Yarn basically is designed to have this map and reduce stage in between which you basically save the data to a hard drive, whereas Presto reads and writes at only once, unless you configure it to have, I mean, in terms of if you have some very heavy queries that you are running and simply the RAM is not sufficient to process the data that is required by these queries, then you can configure the tool to basically spit the data into disk for some certain stages if there is not sufficient RAM available. All right, so what are we going to do is today I have prepared, as I mentioned in the very beginning, few examples. These are the definitions of two tables that we will be dealing with today. All this data has been like created or generated within Presto engine as well. So one of them, maybe let me quickly say what we have in here. So one of them is a table that has sales. As you can see, we have some IDs in that table. We have information about promotions, discounts, the shop ID, which the sales belong to, and then the values for sales, gross, net, and the tax. The other table is the one, so we basically can join or we can run some joins within our or during our meeting today. So it's a simple table with only two columns that will contain the shop ID and shop name. But so if you look at this, if you look at this definition, it's very different from a regular like relational database engines. If you see the bottom after the column definition, there are few elements of the table that I believe needs to be explained in regards to the Hadoop environment. One is partitions, which is basically a physical split of the data between hard drives. Then we have different storages, which we'll talk about in a second, and then location, which is basically where we store this data. And then within properties, we actually keep some metadata of the files that are stored within that particular table. Why files? Because in Hadoop environment, or basically in Hive, which is a like main warehousing system for Hadoop, everything is stored as a file within a database. There is a metastore that contains all the information about these files. So it can keep some statistics. It keeps the information about the format of the file, because we can have multiple formats that we'll talk just in a second. And then if you look at the structure of the folders, then you can see that we have basically within the path, we have a location of the database, which is basically named in our case VIP_webinar DB. Then we have a name of the table as a folder, and then we have another folder, which, if you remember on the previous slide, we had an information about partitions, which is basically an information about what is the partition name and what is the partition value. Now, if we look at these formats, these are the four most common that you can find in this environment. Regarding text files, what we can say about them, like that they are sequential reads. So basically, you need to read, if you want to retrieve a row number 400, you need to read 399 rows to get this row 400. And then in Hadoop environment, it doesn't matter if your text file is compressed or gzipped. By default, gzipped files are also read by Hive, and you don't need to specify a separate value for or parameter or property for the compression type. Why? Maybe let's start now. Let's go to Parquet. It's a columnar storage file that you can also compress with given parameters, depending on the compression type. I will not go into details right now since we don't have much time, but it has some pros and cons. I mean, every compression type has its pros and cons, depending on the type of the table, or basically what purpose the table should serve. Is it like often queried? Does it contain large files or small files? What is the default block size in your Hadoop environment, and so on and so on. Avro is mentioned by me just because it exists there. I haven't seen any tables actually. I haven't worked with that so often, but as you know, it's based on a JSON file, or basically on a JSON schema or JSON type. And then why ORC is in different color is basically because Presto or ORC was very tightly developed with Presto. So basically Presto is meant for ORC. And it has the best compatibility and best like response times or querying times for any for the data, yeah, with this file. It is also a columnar storage. There are some, just briefly saying, there are some stripes within this file. There are indices within this file. If you specify in the properties of the table that the ORC should create the index, for example, within the header. And also it contains, like within the file, you can find the statistics about the data that a particular ORC file contains. So for example, min max of a particular column, and so on. Then turning slowly to the main part of our meeting today, what is the like regular daily, how does the regular day of work look for data engineer? Is, or basically like in general, how do we transfer data to this environment? You can have different options. You can have Kafka, for example, that will be streaming directly to a table. But in general, when you do migration, in most cases, when you, for example, export data from Postgres or from SQL Server, you end up with text files that you simply put in one given location that is designed for this. And then you start doing the transformation on these files within Hadoop environment already. So in our case, what has been done, we'll get that in a minute. The data was generated as text files. Then we basically do transformations on these. And usually the first step is to change the format of the text file, either to ORC or Parquet or any other type. But then, like when defining the structure of the table or the structure of the database, you need to also take care or remember about partitions. If we have lots of data and in big data world, let's say, all fact tables contain partitions. Then there is also this importance of the file size within a partition. Is it too big or too small? What is our block size? And these values need to align with each other. Then we need to remember what, or like choose what should be the compression type. Do we need to have transactions or not? If it basically an environment that we have today is during our webinar is based on Hadoop 2.6.5. Recently, there was a release for Hadoop 3, which gives you like native support for transactions. So then, depending on this environment, we need to also think about that if you would like to support it, or we stick to the non-transactional tables. And then how we will schedule our jobs, and what should be the storage. Is it within the HDFS environment, like local one that is like on hard disks, or maybe if our environment is hosted somewhere in the cloud, if we should S3 or the Azure Blob storage. That's all the considerations that need to be taken in account in order to have the environment. So thinking that what I've just described, as you can see, then in our database for today's meetup, currently we have a few tables. What I would like to start with is first to like let you know how you can find out what is the location of your table. There is a command for this Sorry, I need to reconnect. What is the command to find out the location of the table? Then you can simply you can issue a metastore operation to get the location of the table. Now, if we look at this particular location, we will see that we have folders with exactly the same names as our tables. Yeah, so we should have raw data partitions, and so on and so on. And these are our folders. Now, if we go, if we deep dive into one of these tables, let's maybe get to the partitioned one. Then you will see that this particular table contains lots of folders, which the last folder is basically the one that is after the definition of the table. It has a special like name where we basically specify that this is a partition name for the transaction date, and then we have a partition value which will contain basically this particular one will contain the data that is stored within that particular day. Yeah. So if you can see, then there is only one file in there that has rather small size, but has yeah. Anyway, let's now jump to the first example that I've prepared for today. So Presto is good for some operations, or basically as it is meant for data analysis or data processing. But there are still some things that done from a Hive are better, are working better. So for this particular case, what you would like to do, or what I like to present, is what we'll do is we will first create a table. Let's assume this is our staging table where we are actually putting some, or we are uploading data from any other systems. I will now copy the data over to this table. We will create a new partition in this table, since that one is also partitioned by the upload ID with some artificial value. And then let's assume that this cp command is basically another system or another tool like NiFi, for example, or the Lambda function that will copy a file over there. And then what we should do is basically we need to first, let's see what happens. You see that there is no data still, because if we are doing this externally to the Hive metastore, it is not aware that there is data. So what we have to do is either issue the repeat table, or there is also another command that is called alter table at partition. And right now, once we refresh the metastore, so basically the repeat table is iterating through all the folders, or like checking the structure of the table and updating metastore, then we can see that our data has appeared over here. If you don't like to like use any SQL engines, you can also issue these commands from command line. For Hive, this is this particular command would do basically the same what we have just done with the repeat table. Okay, so right now we have our data in the staging, and we would like to move it to the production. Yeah. Then what we'll do is we are creating the table with exactly the same structure that our previous one. Yeah, so it will have row ID, column, sales gross, and so on. It is exactly partitioned the same way with the upload ID. And now, what are the ways to move it to production? So one of them is what you can do: insert into the production table with the where statement, where you specify the value of the given partition. Or if you are doing this again externally, as we did it in just before a few minutes, you can then also create a new folder within that table. Then you can copy over the data from the staging table to the destination table, and then either refresh the destination table or alter or add new partition so it is visible, just basically what we've seen before a second. If we won't do that, then basically the table is not aware of this data and it will not return any results on the select statements. And then at the very end, you need to delete it from the staging table. Or there is another option, which I haven't actually seen anywhere when I joined the teams that were working with this environment. There is no, I haven't seen this at all, where you can basically within one command do what we would do with all of these, what I've described before in a few minutes. So basically what we're doing here, the exchange partition command, what it does, it will basically move this particular folder. If you look again, this is basically the folder that contains the data. So if you are specifying exactly that particular partition, the exchange partition will move the data from one table to another one. And then we should be able to see that in there. Yeah. Okay, so this is one of the things. So basically, like in general, I believe every metastore operation should be done in Hive. With Presto, you can still issue them, but I believe Hive gives you more possibilities because this is like a native engine to manage this data, but also yeah. All right. So now turning into some other stuff that is also not possible to be done in other systems, or maybe not in all of them, is basically how you can define your destination table. There are multiple ways how it can be done. The one that is the regular one, which is basically so this, assuming this is our source table, we create our destination table that is also partitioned by the same field as the source table, and then we just copy over the data to this table. Another option that is viable or gives you some, let's say, different overview of the table is the table where you can define the column as a row. What it means is within a column, you can nest multiple columns, and then you can refer to these columns with dot, basically. So how you can do that is when you select, so assuming for comparison, let's open this table. So what we do here, we basically select the same row ID, but we aggregate the cells into one column of a row type. And in this particular case, we aggregate all the cells, which is basically the, this one, which is basically the sales gross, and then we will refer to this as sales.gross. Then we aggregate to the same column sales net, and then we will basically refer to this sales.net, and then the tax, which is sales.VAT, for example. And the same we do, for example, for promotions. So we do attributes of the particular row of a particular transaction in our database, which will be attribute at attr.promo and then attr.discount. And this is how you can create table that will have or contain exactly the same data, but in a different way. And the third example that I would like to show you is the one where we actually use some another type that is available in not only in Presto but in general in Hadoop environment, which is a map, where we actually define a map by aggregating or like creating two arrays, and then within Presto a map function will join these arrays on a specific position within the array of a given field, and then we create a map or a JSON, however you want to call it. I mean, basically it will be a key value pairs. Yeah? So gross will belong to the sales gross, net to the sales net, and then VAT to tax VAT. Now, if you look at the definition of the table, they were defined exactly the same. So now let's see now if any of these has different size, because this is something that we will be looking at. So one more time. So if you look at the size, the total size of these tables, they are more or less the same. The one with maps contains the least space. The one with rows contains the most, but in general, the differences are only a few percent. But if you have, in these tables, we currently have 170 million rows. If we issue count on these tables, yeah, the row count will be the same. So if the total count of rows in these tables is 17 million rows. So they are created with ORC, and they all contain around 240 megabytes. I mean, they take around 240 megabytes on the disk. Now let's see if the queries, or basically the same queries applied to these three tables, will differ in terms of the time required to query them. So for this, let's see at the UI. And these are the three top queries that were issued. And if you look at the memory usage, this is the peak memory from the interface. It's more or less the same. And then the cumulative user memory, so how much RAM actually is required to process everything. The one with the maps took most, but still these are the values that are very small, or basically like irrelevant to the available RAM. So in our current setup, I have configured it to the maximum 4 gigabytes of RAM for the query. Now, since you are here first on this UI, as I mentioned, this is very intuitive, first of all, but it also gives you lots of information about what is happening within the query that you are running. So first of all, these are the statistics. So if you look, we have in total, we had 79 speeds for every query issued. So basically, like the plan was more or less the same, because if this is a bit different in terms of processing or like how the query was scheduled, then you'll see that it will differ. Then we have a total time required by the query, the statistics about the resources required. Now, if we look at a specific query, what we can get from here, sorry, is basically, first, this is an overview. So what was issued and who did it, basically in the top, from where, what was the connection type, and so on and so on. Then I believe this is the most important page for data engineers, where you actually see what was happening within each stage and how much data or how many rows were processed within each of them. So if you look, if you see this, then we had for this particular query where we just do simple select with group by, there were 3 stages. The first one was scanning the table, and scan is basically doing a quick check on the ORC. Oh, sorry. If we go inside this stage, then we can see what was the performance. So what was the output? How much time it actually waited to be passed to another stage? And then, so first we were scanning the table. Then there was a local exchange, which is basically an exchange between workers, what are the keys required, and then aggregation. And at the very top, we have the output and the number. And at each stage, we have the number of rows that were sent to the next one. So if we see the result should contain 640, where is it? 643 rows. And in here we have also, but the first stage was actually reading the 17 million rows that are in our tables. Okay. The next example is on big table versus small table join. So I have one query that what it will do, it will basically take the data from the raw data table, and it will join it on a key on a shop ID to get the shop name from our dictionary table. Yes. In the first place, let's see what will happen if we issue after the from select, we will issue the small table and we will join it with the big one, which is our fact table. Let's see in the UI how many resources we will need for this. This is one of the things that we have to be very careful, not only with Presto, but with other engines that are working or you are operating within Hadoop environment. Yeah, so let me quickly change this, and in the meantime, then we will be able to see. Okay, so this one's like, so if you look at the first one with the big join, let's see also the plan for this. Let's see what happened here. If you look at our plan, you can see that there were there was 1,000 rows, which is basically our table with shops. There are 120 something rows. And then our fact table was actually exchanged, which means like all the rows that are required by the query were hashed and then exchanged between workers. And after that, the join was done on the table. Now let's see what is the result of the other query, where we basically select from the fact table and we join to that dimension table. So if you look at the memory peak, it required a lot less RAM to process all the data. And then if you look at the cumulative user memory, it also is significantly lower, like 10% of what was required by the wrongly, I would say, reissued query. And then if we look again at the plan, then we can see that basically it looks more or less the same as the previous one. Yeah, it is. I mean, it is the same in terms of the number of stages and how the stages were organized. But if we look closer into like the first stages that start reading the data, then we see that the local exchange was done for the dimension table and the fact table was streamed. And this is the most important thing you need to remember when working with this tool, that every table that is after the from closure is streamed through every stage. So if we had like 4 or 5 joins within our query, then there would be stage 6, stage 7, stage 8. They would all have local exchange and hashed values basically passed to the left join or inner or whatever join that would be there. And then once these were loaded into the engine, then it would start reading our fact table and then join them in memory. And after that, aggregate again. We see that in this stage, there were 60 million rows passed. But after our group by, there was only 1.27 million rows. And as the result, we have received 384 rows. Okay. Another thing is, I think this is an example of what you shouldn't do in Presto. So there is a common feature that you basically as a user create a table, and then you issue insert into statement to basically load the data. Yeah. In Presto, you can there is a limit for the string, which is few thousand characters. I don't remember now what is the exact value, but then basically your query would contain lots of data that would be cached basically within this UI. So if you see that, first of all, this is visible here, but then if you go, but in here you will find only the first like 6 or 7 lines of the query. But if you look at the live plan, it will always show you, at the overview, it will always show you the full query. And what I experienced that users in their R codes or in Python, they were issuing this insert into query with like, the value like very close to the limit. And then after like 10 or 15 inserts like that, basically the cluster was shut down because the caching that is done for the UI was not able to handle so much data within. So basically then, of course, after restart, everything worked fine, but it was unavailable, and the administrator was had to like restart or start it from scratch again. Then we come to this to the more interesting stuff. So I have prepared for you 3 ways or basically a query that gives you the same result. And what it does is basically it aggregates the sales hourly, but also alongside it provides the sales for a given day. So let's see. The first example is with the window function. The second example, we will issue exactly the same query, or like the query that will provide the same result, but with the join. So we will first aggregate it on the hourly aggregated hourly. After that, we will select from this hourly aggregates, and we will aggregate it daily. And then we will join these 2 results. So we will take from hourly or from which is basically more, and then we will join it with daily. So let's see, our first query has finished. It took only 1 megabyte of RAM, because if you look, it is again, this data was streamed. The store list was hashed and then exchanged between all the workers. And we issued the where statement, which was basically filtering our data set by only a specific shop ID. This is like important if you are trying to sample the data set and you want to analyze. The other way you could do that, I mean, this is assuming like this is the first shop, or you want to test aggregation for 1 shop only. Another way how you could do that is with the limit. So basically you process the whole table and you apply limits to select the first you order by the shop name, the transaction hour, and then you limit 24 because you have 24 hours within a day. And then if we look at the UI, we'll see that this one will take lots more RAM because it's basically processing more data. If you are like issuing these kinds of queries in other ranges, you probably don't have a visibility to what is the resource consumption. And here everything is explained quite easily and understandable. So let's now issue the join, and let's see with the where statement. And let's see the plan for this. So again, we are aggregating hourly. Then we are taking this aggregates from hourly sales, and we are we are aggregating hourly. We are taking these aggregates and aggregate again daily, and then we join these two results together to get the same output. And now let's see what is the plan of this query. If you look at this, these stages in the very bottom, they look very similar. And if you take a closer look at them, it actually turns out that even though we have selected the hourly aggregates from, the daily aggregates from hourly, it is still reading the fact table 2 times. Yeah. So with this join, what we have actually done is basically we have duplicated the number of data that had to be read into our query. If we now take a look at the one with the window function that we issued in the very beginning, then you see that this read was done only once. The last example is about some functions. So basically why I really enjoy working with Presto, because it provides lots of functions that work on not common data structures. One of these is the or basically a map aggregation. So the function, what it does, it basically takes the distinct values for the transaction, for the hour of the transaction time, and then it will aggregate every row of the sale to an array. So if we issue that one, let's see the result. So if you take a closer look at the hours to sales mapping, we can see that our keys and value is an hour 0, and then we have aggregated to an array all the rows that were found within the table for a given key, which is the transaction date and the shop name. And it applies to every distinct value of the hour per day. So what it actually represents, this array, is the value of a sale that belongs to a given row within a particular day and hour and the shop. Then what we will like to do with this data structure, we apply a function that allows us to iterate through all the keys in that map, and it transforms the values. And how it transforms the values, this is the function that we will apply to an array of the values. And what it does is basically we are taking the value of each field, and then we are calculating a sum of an array for each field. If these structures might be more complex, so if you would like to calculate the average, for example, then you can add also here the not only sum but the count of the values, and then at the very end, instead of like releasing or like saving or showing to the user only the sum, you could create an array, and then the first field can be, for example, sum, the second field can be, for example, count, the fourth field might be, for example, the count of zeros or count of values that are higher than 30, and so on and so on. So within the reduce function, if you look at the documentation on the Presto site, you will be able to basically the output of the reduce function is like one value, but since we can aggregate it to arrays and maps, then you can deliver multiple statistics regarding the given array. So within here, we will do the hourly sales, and then with hourly sales, what we do, we again reduce the map values for hourly sales, and we will calculate the daily sales. After that, once we have these aggregations, because this will again be an array, we can unnest it. So basically what we first do, we are pivoting, like aggregating rows to one row. We are transforming these values 2 times. And then as the final result, we are expanding this array, or like pivoting it from being from one row to as many rows as the map keys were found for a given shop and a date. So these are not only examples of how you can apply different functions of Presto to data analysis and data engineering. Another thing is, for example, the sort. So we have the again, we are aggregating everything to a map where we have hours and sales, and then what we can do, we can sort our array. Maybe run it. We can sort our array descending. Sort our array descending, but not by the full number, but by the fraction. So if we look at the values, you'll see that every fraction in the next element of an array is lower, because this is what kind of a condition we have applied. Thanks to that like syntax, or like ability to pass a function to array sort, you can invent your own sorts, types, whatever you like. For example, if you had null values in this column, then you can sort either null values in the first place and then sort everything else descending, or sort in the first place everything ascending and then put null values at the very end. Thanks to these arrays and maps, once I was working on a project that basically had terabytes of data. We were able to aggregate over 20 terabytes of data within a 300 megabyte RAM that were hosted on our that we had available within our cluster. These are not the only examples that I like Presto for. If you look at the documentation, that has plenty of different functions. So for example, if you are working with geospatial data and you have polygons, then there is plenty of functions that will allow you, for example, to quickly find if you have the location, latitude and longitude for a given point, find quickly a location in a given polygon. So for example, finding out all the cities in your table that belong to a given district in the country, or within a city. And then if you are working with URLs, if you are working with JSON, then you can also easily do everything that is required by your analysis. And this is why I like it, basically why I always try to have it in the working environment that I'm working on a project, because thanks to these functions, you basically don't need to, you hardly ever need to write some external codes. Or yeah, so I believe that that's concluding my presentation, and we have still a few minutes for questions if there are any, so please. Yes, Gleb, let me. Yeah, go ahead.
Oh, okay, cool. So, kind of rookie question probably, but how, because sorry, I missed the beginning. I believe you mentioned that Presto is like not like MapReduce, so it is not storing some intermediate results on disk. It is just, you know, totally fully in memory technology. I just Googled it a bit. Is it like very similar to Impala from like its purposes? It is more like MPP. I mean, massive parallel processing engine, more like this technology type, or it's comparable to Hive mostly?
Yeah, so it's rather an MPP engine. As I mentioned, since like 5 or 6 versions, there is an experimental feature that you can spill data on disk. But if you look at the plans of all the queries that I have issued, everything was passed. Everything was passed from stage to stage within memory because I haven't configured it, and because basically it slows down. Yeah, if you have really like heavy queries, there is always a way how you can engineer them to reduce the requirement. So for example, if you are processing 1 day of data and it would require 3 terabytes of RAM, don't process 1 day, process it hourly, and then aggregate the results somehow. Yeah. So from that perspective, everything is possible. It just requires a bit more effort, but basically I had one as a pipeline. Okay, so now you mentioned you made a comparison to Hive. So yes, it basically what it has in common in Hive, that it is the meta store. So it takes all the metadata of tables from Hive, and also it updates the meta store of Hive with any changes that it does to tables. But in terms of the engine, it is completely different design. It doesn't use anything that was shipped with Hive.
Okay, yeah, and yeah, I believe you also showed it like at the beginning when you added some file and you just needed to refresh the metadata, yeah, from Hive Metastore.
Yes.
Yeah.
Yes.
So you just, you know, remember how it was done for Impala, so just.
Yeah, so you can compare Presto to Impala, but I like my personal preference is towards Presto because of this set of functions that are not available in Impala, especially when it comes to working with arrays and some more complex structures. It basically in Presto you are somehow mixing SQL with programming, I would say, or like array, or like basically with programming. Because not only you have access to like regular data structures, but as I showed you, you can work with polygon data and so on and so on. It just needs to be put to a table in Hadoop and that's it. And it will take, and Presto will be able to query it, of course, if the data is not broken. So from that perspective, and also the most important thing about it, if you look at the page, it has many connectors to other database engines, and not only in Hadoop, but also relational ones. So once I had a setup when Presto was connected to MongoDB and to SQL Server, at the same time. And basically you can select data from SQL Server. You can then join it together with the Hadoop data, and for example, save it to a MongoDB table.
Okay, those are some native connectors, so they're like, you know, they're pretty quick from fetching the data, so not like row by row and other stuff, so they are somehow connected natively to the database via JDBC or something.
Yes, the only thing I experienced, for example, with MongoDB, so if you have some really complex structures of JSONs, Presto is not able, or at least it wasn't able a year ago, to retrieve some specifics that are nested within these JSONs. You know, it was or basically like filter them on the database side. What you needed to do is to gather the whole row to Presto, and then you were able to process it. And so that was the downside. But I don't know how it looks now. But for simple queries, where you have like, let's say, one or maximum two nested or like two level JSONs, then it should work fine. Yeah. But if there are some arrays within the JSON file in MongoDB, then as I mentioned, it affects the network significantly, because I was also like together with the DevOps team monitoring that part. But still, this possibility of gathering data in one place for multiple systems, I believe, is worth considering in any environment. Yeah. And plus is that AWS Athena is based on Presto as well. It's version 0.174, so it's like 3 or 4 years old still. But anyway, like in this version, you already have arrays available because they were introduced like 4 versions before that. Yeah, I mean, it's worth looking into it, especially when you don't have a fixed environment, meaning, for example, you have yeah, at least you have a possibility to experience with this.
Okay, thanks.
All right, so if there are no more questions, then thanks everyone for coming. I hope you enjoyed it, and I was able to give you some insights into what data engineering in Hadoop more or less looks like.
Yeah, thank you, Przemek, very much for sharing your knowledge with us, and thank you everyone for your participation. We hope you had a great time and you enjoyed the webinar. As I said, the recorded version of this webinar will be available. We'll send it to you via email. And if you're interested in our upcoming events, please follow us on Facebook or find us on meetup.com. So Przemek, once again, thank you very much. And see you online soon, I hope. Have a nice evening. Bye-bye.
Yeah, thanks. Bye-bye.
Yeah.